In this module we're going to talk about segregation of resources, and in particular we're going to talk about some of the options for making better use of large hosts. Right, so the most obvious way to segregate your resources is, of course, use multiple hosts. And for the most part, with people implementing in the cloud and things like EC2, SoftLayer and others, this is how they segregate things out. They let someone like Amazon or one of the other cloud providers provide virtual machines to them, and they allocate them as needed up to the maximum size, pick the right size, that kind of thing. But what happens if you've actually got hardware? What happens if you've actually got big servers and you want to get the most out of them? If you've got, a very large server, something on the order of, say, you got 12 cores, 512 gigabytes of RAM. Maybe you've got a SAN for your disk, so that essentially gives you as much disk as you want, so it's essentially infinite as far as you're concerned. Maybe you've got a SAN plus some SSDs here for the local storage for the stuff that you want to access rather fast. So you've got this very beefy sort of machine, and in fact this may even be 24 cores, could be 2 by 12 cores, could be 4 by 12 cores, depending on how this works. But you could have essentially a highly over-provisioned machine. It's very unlikely that unless you're really working hard, a single MongoDB process is going to get up to this. Now it could. In particular, you have to know where your bottlenecks are, so that is key. So if you want to put more than one MongoDB process on here, going to want to know exactly where your bottlenecks are. For example, if you have a working set that's approximately 400 gigabytes, then you're going to be using 80% of your RAM just to keep that working set in memory. And in that case, because RAM is your single limiting factor essentially, and you could fit 400 gigabytes of data into MongoDB pretty easily, so that might be just one MongoDB process. A working set that size might be slightly unusual though. There certainly are those types of data sets out there. But it's more likely that you're going to have some sort of smaller multiple there in terms of what your working set size is. So imagine you've got this host with quite a bit of RAM, as much disk as you want, plenty of cores, and you know that your working set size is something on the order of 80 gigs. So you're thinking, well, how can I best provision my data set in here? So you might think, well, okay, I can put multiple MongoDB processes on here, but I need to be careful. I've got an 80 gig working set, but what else might be the bottleneck here? Well, you've got your memory covered. That's going to easily fit in, and multiples of that. 5 of these could easily fit into that amount of RAM. So you could have 5 processes with 80 gig on there. So that's memory covered. So you know that you've got at least 5 processes worth of that. So then you think, well, what else have I got here? There's I/O, right? You have to benchmark your I/O. How much I/O is required to keep those working sets in memory? You benchmark that, and it turns out that it's not quite up to 5, but you're pretty sure that you can squeeze 4 processes worth of I/O out of your SAN or your SSDs before you're going to hit a bottleneck. So you've already gone from your 5, your easy multiple of 80 gigs into 512, and you're down to 4. So you're thinking, okay, well, so 4, that's still a pretty decent return. What else might happen here? Well, it kind of depends on how you're going to use this. What if you're going to have a very high number of clients? What if you're going to see a very high number of connections? And the churning through connections can surface in multiple different ways. You can run out of file descriptors. We've seen that already with ulimits and such. You can run out of file descriptors if you have too many concurrent open connections. So remember that each MongoDB process can have 20,000. So if you're going to load all of them up, and let's actually put in a bit of a buffer. Let's say you're not going to completely max them out, because that would be a bad idea. So let's say you think that these are going to be very busy. You're going to have 15,000 connections per MongoDB process. It's going to be lots and lots of clients connecting here and reading this 80 gig data set. So you do some quick mental math and you think 4 by 15, that's coming up to 60,000 concurrent connections. Well, now that's interesting, because that's going to use up 60 gigs of memory for one thing. But you think you've got enough overhead because you're down to 4 processes. 4 by 80 is 320. So adding in an extra 60 gigs of memory, you're okay. You're still okay with your 4 processes, so that's still working. There is a little bit of a danger sign here, though. 60,000 concurrent connections, you're going to start running out of just ports generally, right? So there's only so many ports available in a particular system. 60,000 is pushing it a little bit. This could be dangerous. You're going to need to keep an eye on this, and particularly if there's a lot of connection churn and connections have a chance of running out. So you think you're still going to squeeze in the 4 processes, and as long as they're not breaching this sort of 15,000 limit, you think you're still going to be okay with your 60,000 here. You're certainly going to have to keep an eye eye on a few things though, and you may need to tweak certain connection parameters in the kernel down, make sure that you don't end up running out of available ports or available total file descriptors. So there you have it. You've sort of come out with a rough benchmark of 4 MongoD processes on this host, based on how you think you're going to use them. And that's the kind of evaluation you're going to need to do. So what I generally would say is, take your nice beefy machine, put a single MongoD process on there, and use it as if you're going to use it in production. Benchmark it, test it, see how high you're using each of your resources. How many ports are in use? What's the non-mapped memory footprint? What's the resident memory footprint? What does your I/O look like? Run I/O stat, which we covered earlier on. How's the percentage utilization looking on those disks? All of these things need to be factored in. I doubt you're going to run into a CPU issue, which is 4 processes and 12 cores, so you're probably going to be okay there. But maybe you're going to do some large parallel processing, lots of aggregation framework, and maybe you are going to run into some cores there. So you really do need to benchmark. So the golden rule, benchmark. Benchmarking and testing is key. I can't stress this enough. If you're going to deploy more than one MongoD process without any other isolation or restriction, if you're relying purely on the operating system scheduler to be fair and to treat these processes well, you have to do your research. You have to make sure that one process is not going to stomp all over the other ones, or you have to be prepared that if that does happen, you're going to have an impact across more than one database. So if one database goes crazy, and let's say somebody makes a code change and this increases to 160 gigabytes, what's going to happen there? You've got contention for memory, you're going to have more churn in memory, you're going to have increased I/O, various other things. So what happens when this goes wrong? These are all things that you're going to have to be aware of, because the scheduler in Linux, although it does provide things like process isolation and things like that, is going to try to be fair to all of them. If one of them is being more demanding and running amok, it's going to impact everybody. So, can I deploy more than one MongoD process on a particular host? Yes, absolutely you can, but you absolutely have to do your research first, and you have to know what you're doing. If you run into an issue like this and you come to MongoDB here for help, this is the kind of analysis we're going to be doing. And if we figure out that, well, you've just provisioned too many, you're going to have to go down to 3 or 2. This host just can't keep up with what you're trying to do with it, despite the fact of how beefy it is. You've run into a bottleneck with I/O, you've run into a bottleneck with the amount of RAM that you can actually access on this host, and that's just the way it is. So your assumption that you could fit 4 processes on it might be wrong. And there's no substitute for actual benchmarking, real world, production level traffic on a particular host to gauge that. Final note here, in terms of segregation of resources on a particular host, it is very tough. In fact, I would say it's impossible, but someone out there may correct me. It's very tough to isolate processes and set limits without going to other solutions. We're going to talk about some of those solutions now in a second, but if you're just running processes on a particular host, it's very tough to set sane limits so that one process can't stomp all over the other ones. So that's the note. You have to be aware of that, you have to be ready for that, and you have to do your planning appropriately.